Hey everybody, welcome to this week's CanJS Community Hangout. We took the last 2 weeks off, but we're back today. We're going to start off with Veljko talking about can models and some advanced queries with them. And then after that, Josh Dean. He's going to go ahead and tell us all about how can.fixture actually works. Then after that, Josh Marichan's going to tell us about some things that are coming up, some potential ways we're going to add functional reactive programming to CanJS. So without further ado, I'm going to go ahead and get us started with Veljko. Veljko, why don't you start off just by kind of telling everybody a little bit about yourself and what it is you're going to be showing them today.
Okay. Hi, everyone. My name is Veljko. I work as a backend developer at Bitovi for, well, nearly 2 years. And I'm going to talk something about making complex queries with can.Model. So here's our use case. Actually, it's a GitHub use case. So on the backend side, we need a REST API that handles complex queries like filtering, ordering, embedding objects into response. In the front end, we need an application that we have an application like GitHub that has a current state. Actually, it's held in can.map, and we also need some kind of UI controls that configure the state, like the filtering options, and every change on a state triggers a new query via can.Model to the REST API and renders the results. So I have demo application here. Here's a demo application that holds the bitovi.com/articles, and we have some filtering on it. So every article for this demo has tags, the title, this is actually an ID, the author, and the published date. This first one is actually in the future. The rest are here, like already published. So we can do filtering by some of these fields, some of these attributes. Like, for example, we want to filter articles that have a CanJS tag and a JavaScript tag. We also want to filter them by author, for example, Justin. And we want to see only already published articles. This first one is actually in the future, so it's gone away now. On the left side, here are some components, can component. And this is basically on the right side only the mustache template that renders the list. So how does the architecture looks like? As I said, we have this current state that is stored in can.map. We have some can components that acts as a filter, like author, tags, and published checkbox. And the only glue that we use here is a listener function that listens on changes on current state and makes a REST API request via model find all, and the result is rendered in a template. Actually, there is no, of course, REST API. We can use can.fixture for that to get to simulate the REST API behind. So I will just switch to the code to see how it really works.
One quick question. So that glue part, is that the model? Is that what you mean?
No, actually, glue is only a function that uses can.Model to make a request and set up parameters.
So it contains a model within it?
No, model is outside. This is only. I will now show the real code, so I think it's going to be clear then. So just let's first go by quick through the template. This is actually the whole HTML. We have filter bar container that's on the left side, the results container on the right side, And we have here 3 templates: store for this select field can component, and for checkbox can component, and the template for the results list. Actually, if you look at the demo, this author filtering select box and tags, they use the same can component, but the can component can have multiple option, can accept multiple option. So basically, this is the 2 instances of the same can component. So in the source, we can see that there are both select. We have select field template that accepts multiple attribute and renders the select form as multi-selectable. We also set the attribute name. We use can value, so we can read the currently selected options inside select, and we also have nullable option in the can component that inserts the default value, like a blank value. The similar thing is with checkbox field template that also uses can value to pass the selected value, is it checked or not, and we also pass the caption and the name inside. So if you take a look at the application, I have defined some fixtures, but that's not the interesting part. We have can.Model that actually only has for this demo find all method, and these are the components. So basically, this is a basic definition of component, which attributes it's using, and on which HTML tag we want to initialize the component. Here's the initialization of components. So we pass like the author as a name, the current state, the author attribute as a state. So that's the value that we'll get back via can value. And for the filter bar, we also use the same can component, but we'll pass the tags attribute on state and as options tags. And now we are going to this function that glues that together. Here's the definition of state, and by default it's empty. So we want to retrieve all the articles we have. Fetch and render articles. It actually, okay, first this. We bind, we listen for change event on the state. We do some kind of sanitization for params, like we don't want to send empty values. And after we have params, we just call fetch and render articles that actually make get request with params via article find all, and render those articles via results list template. So actually, these 2 functions are the whole glue that connects these can components with the REST API. So of course, if we unselect all the filters, we will get the list same as on the beginning. And Chris, did this answer your question?
Oh, that was me with the question, but yeah, you answered the question.
Actually, this is where I connect the values in components with the can.Model and the send parameters.
Can you show the results list template again? I don't see that.
Sure.
Oh, can you show? Oh, okay. Oh, there we go.
It's a basic can mustache template that just render the things. There isn't any component or can control behind it.
Gotcha. Cool.
And I'm using this can value to get the currently selected values in this select and input fields.
Is this code somewhere online that people can see?
I will make the GitHub gist or something, so we can share that. Sure.
Cool.
Any other questions?
Well, it doesn't sound like it. Thank you. And go ahead and, once you get that gist up, give it to me, and we'll send out a tweet with it later, along with just everything else that comes up. Awesome. Thanks, Veljko. And now, Josh Dean, you're going to teach us how can.fixture works?
Yep, uno momento. Perfect. All right. Ooh, that's nice. So I'm Josh Dean. I'm one of the JavaScript developers at Bitovi. As Chris said, I'm going to talk a little bit about the can.fixture underpinnings, basically kind of what actually powers CanJS as a whole. So, like I said, we'll talk about what can.fixture is, as well as kind of the power behind it, and then what happens inside of a can.fixture when it gets put on the page and when it's running. And if we have a little bit of time, I'll show a quick demo to kind of show a little bit of the underpinnings. So first and foremost, what is can.fixture? If you are unaware, can.fixture is a utility library part of can that simulates AJAX calls. That is, it will take an AJAX call that happens going out to a server, it'll trap it, and rather than going to the server, it will simulate the response from the server with either say a JSON file or a function. What this really allows us to do is it allows us to very neatly develop and test JavaScript applications completely independent from some sort of back-end API system. If we want to kind of take a look at this in a picture, here we have what we'd expect. We have a web page and then a server. Typically, what happens? A request goes out to the server. The server will process that request, and they'll send back some data through a response to the web page. What can.fixture does is it shoves itself right in the middle of your web app and the server, and basically says, "No, not quite. We're not going to go to the server here. You're going to get some fake data back. Also, it'll take the request, it'll do something in order to come up with a response to get back to the server." How this is powered is really neatly through some low-level jQuery AJAX APIs that most people don't know about. The first function API it uses is something called the AJAX prefilter, which will handle custom AJAX options that you pass in, and you can go ahead and modify them and process them before the actual meat of the jQuery.ajax call happens. We use this to basically detect what type of fixture, what type of AJAX call you might be making, and then if a fixture exists, we will process your API call in order to either use a fixture if one exists, or go straight to the backend server. The other one is a little bit neater, and it's called AJAX transport. And what that does is it creates an object that actually handles the transmission of whatever AJAX data you're going to send based on some sort of data type. That data type is this AJAX transport is actually what we use for dynamic fixtures, as opposed to what we do with non-dynamic ones, which I'll talk about in a few minutes. For the non-jQuery libraries, because can does support them, they don't have AJAX prefilter and AJAX transport. So in their version of can.ajax, we essentially simulate both of these out of the box for you, so it still works in the exact same way. So for what happens inside can.fixture, a couple of things happen in a particular order. So first and foremost, can.fixture gets added to the page either because you stole it, you required it, you put a script tag that has can.fixture explicitly on it, and then it runs a bit of code. The first bit of code that it runs is it calls AJAX transport, adding a fixture data type, which again, as I mentioned prior, is what is used for the for dynamic fixtures. Dynamic fixtures, again, being basically custom functions rather than static, say, JSON or XML files. But anyway, the next thing that gets called is we have a pre-filter function that gets added to the AJAX pre-filter that will go ahead and sniff the options that you pass to your AJAX call to determine whether or not a fixture call can be made. Next, somewhere down the lines, let's say we add a new can.fixture to our app, say, just for generic sake, get pull event. That fixture's URL gets parsed and saved somewhere in memory inside can.fixture. And if you have a static, depending on if you use a static fixture, e.g. some URL to a JSON file, for example, or if you use a dynamic fixture, one of two different things happens, which we'll see right here. So you create your AJAX call, or you create your fixture, and now you make an HTTP GET call to pull events. What happens is, no matter what, AJAX pre-filters gets called, and it goes through and checks your URL, and it sees if it can find a fixture matching for get pull events. In this case, we do have one. And depending on whether or not it is a string or a function, we do two different things. If it's a string or a static fixture, we modify the settings of the AJAX call. We have the URL instead of pointing to the original API URL, it will point to the JSON file, and no matter what, it will set the type of the AJAX call to get. If it's a dynamic fixture, we set the data type to fixture to be later on processed by the AJAX transport. If no fixture were to exist whatsoever, say for example we did post pull events for whatever reasons, it would just transact the AJAX call normally. So at this point, if we have a dynamic fixture, our AJAX transport fixture object gets called, and we go ahead and we remove the fixture from the data types, and then we simulate sending out the call. And when the send function of AJAX transport gets called, what it does is it gets the contents from the the dynamic fixture, and then it sends back a successful callback. If we choose to abort the AJAX call, it won't. It will just call fail as normally expected. There's a lot to go through really quickly. Are there any questions? Cool. So I do have a little bit of time to do a really quick demo. I want to take something that people would probably be really familiar with. So what I chose to do is I decided to borrow our demo from CanJS.com, which most people see if they go to CanJS and they're kind of looking things over. And so what I ended up doing was I need to actually switch my screen share here real quick to screen one, share. And what I ended up doing was I kind of went through the bits of code to kind of try to show where each of these get called. So we can kind of, just as each of these functions get called, we can, console log out and see through the console what gets called. So here you can see we hoist the, or not hoist, we monkey patch the Ajax prefilter and Ajax transport functions, just so we can do, you know, console.log our prefilter and our transport functions were called, and then we go on and call the rest of the app. Inside of can.fixture, we put a quick console log in showing the prefilter that gets called for each and every Ajax call, and then another one in case, you know, we do our Ajax transport for a dynamic fixture. So in the demo that we currently have, everything is a dynamic fixture. So what we should expect to see is the prefilter gets called, the transport gets called, and then whenever we make an Ajax call, the prefilter update filter function gets called, as well as the transport send function getting called, which, real quick, we'll go ahead and make sure that happens. If I can also figure out how to make this go up in size, that'd be fantastic. There we go. So on load of the app, the little applet, you can see, you know, the prefilter function gets called first, followed by our Ajax transport call. When we go ahead and initially load all of the to-dos, the prefilter function gets called to check to make sure that we have a fixture in place for it, which we do. And since it is a dynamic function, the Ajax transport gets called for the fixture data type. And anytime we go ahead and edit any of these, you can see that the prefilter gets called, checks to make sure that the Ajax call happens, or exists in can.fixture, sees that it's a dynamic fixture, and then calls the transport one to run the dynamic fixtures function and then send back the data. We can do that a couple more times. Read the guides. Let's see. Read guides. Build your app with component, and you can see every time that I update, both of them get called. We're not going to become immortal, but we will get a haircut, not at 2. We're going to go get that done at 5 p.m. instead. Getting a little shaggy. All right. Make sense? Any questions? Anything I can possibly explain a little more?
No questions, but it's really interesting.
Yeah, there's a lot of really interesting, there's actually not a lot of interesting APIs. That is a complete and total lie on my part. There's exactly 3 low-level API functions to jQuery.ajax. can.fixture uses 2 of them. It uses Ajax prefilter and Ajax transport. The other one, which is really neat, but not only is not really used, but they don't recommend you use, is the Ajax setup. Which works in a kind of a similar way to how can controls work with setting up options and default values. Basically, on every Ajax call, it will call the Ajax setup function, and it will allow you to manipulate the options you set with default values. It's something that's really handy if on the low level of, say, perhaps maybe can models. If you want to set very simple default properties and options to your Ajax calls that, say, you or other developers don't necessarily want to have to worry about entering each and every time.
Yep. No. And I'm really glad you talked about it. I mean, I think a lot of people know about prefilter, but not very many people know about transport. And I definitely push everybody to look into it because there's a lot of really powerful stuff you can do with it. A lot of automated stuff like you're talking about, Josh, with filter and transport. So definitely look into transport. And that said, I'm just going to kind of segue on to the other Josh, or he may refer to himself as the real Josh. That's up for debate, though. So, Josh, you want to go ahead and walk us through what's going on with FRP and what FRP is for the majority of us?
Yeah, so FRP is just a fancy name for what I'm going to generally refer as the... Can you hear me okay, by the way? Everything's good?
Yeah.
So there's this idea of event streams that instead of doing, you know, handlers that you put right on events, you start creating these streams that have event values going through them that are triggered by some original event, and you're able to transform them, filter into each other, merge them together. So it gives you very high level control. So for example, whereas you would usually have window, let's say you have this event, right? Window dot on click function. Right, this is pretty standard. Ignore the other one for now, but you can see the log here, right? So this is how you usually do things now using a library kind of like CanJS, which is loaded on this tab. I can do can do var mouse downs, and here we have a first class object that kind of represents every time something got clicked. So we can do mouse downs dot log, and then mouse was held down. You'll see the log here. Now the thing is, I can also then go like I can do like let's say I have our mouse ups. Right, so now I have mouse downs and mouse ups, and I can do var mouse is down stream, and this is going to be mouse downs, and I'm going to map that to true. Basically, every time that an event comes through the mouse down stream, I'm going to create another event stream here that will return true every time there's a mouse down event, and I can then merge that with mouse ups. Let me hide this thing. Mouse ups dot map to false. So I'm going to create, here's one stream that returns true every time the mouse is pressed down, and here's a stream that returns false every time the mouse is up. And then I merge them together, so what I'm going to get is a stream that returns either mouse up or mouse down, depending on the mouse down state, right? So I press and I release, and you can see mouse down state changing. Now you can, you can keep going down the rabbit hole with stuff like that, and this kind of stuff is memory safe as well. So those, unless you have something that will actually trigger a final side effect, in this case the log statement triggers that, you're not gonna actually have the event handler in there, so it's nice and safe. Any questions so far? This is like the very basics of the neat stuff behind event streams. Before I move on to the can side of this.
What would you say is the big benefits, other than just different syntax? But what are the other benefits of this style programming versus traditional?
So I think the biggest benefit to something like this is, apart from different code organization, it becomes very easy to do very complex event interactions. So I think a lot of us have gotten to the point where we basically write state machines into our controls or components to write things like, say, drag and drop. Or we have some event that depends on something else, so we have one event set a flag, and then we have another event that's always listening that simply sets a flag, that looks for that flag and either returns early or does some special thing. This makes it very easy to handle that and very natural. On top of that, it's very easy with this to set up temporary event listeners that are triggered by other events. So let's say you have a drag and drop thing. You can have an event stream that exists only as long as the current mouse down. Let's say you have a listener for mouse moves, and that listener for mouse moves, that specific instance, will only last as long as the current mouse down event, until the next mouse up event. And I'll show you some code as far as how that looks like. Now enter I'm using, in this case, this Bacon.js library, which is excellent and covers a lot of your bases. It also comes with a very large library of, you can think of Bacon as like the Lodash of event streams. So you have all these like higher order functions that let you manipulate event streams from a very high level. You can throttle event streams, you can debounce them. What else? You can negate them. You can have some kind of side effect action, like insert a prevent default in there, and reduce all these things that you'll end up collecting as you go along. I also integrated Bacon with CanJS through this library that I'm working on right now called can.Bacon. And what can.Bacon does is it extends, it implements this can event stream interface, which is kind of where it's at right now, which extends CanJS such that all these events that you get from CanJS, like through can.bind, events from map, compute, even DOM events from can control, all of those you can create event streams from, and it makes it very easy then to just integrate all the stuff. So that's the basic gist of it. I'm not going to go into the specifics of can.Bacon, but what I've been working on lately is this can event stream library, and this is going to be a plugin for CanJS. This is where the CanJS part comes in. So this is a plugin for CanJS that's going to add FRP features straight into CanJS. So you can just load this plugin up, load a plugin that implements the interface, and you can go ahead and start spitting out event streams. Use Bacon. There's two supporting libraries for it right now. There's can.Bacon. Where is it? There we go. There's can.Bacon over here, and there's can.Rx if you're familiar with RxJS. Both of them are supported. So kind of where we're at right now is I'm working on this ticket here. You see this 1218 on CanJS, and this is all about how to bring these features into CanJS, what the API should look like, what use cases people have. So I am very much looking for feedback from people who are interested in this stuff. I'm going to start collecting resources for people to learn FRP. I think this is something that could set us apart quite a bit from other libraries. I don't know if any other MVC frameworks that are integrating FRP into their thing. There's plugins for a lot of them, but nothing that's really trying to do first-class support. Yeah, I think is that 7 minutes?
Josh, I got another question.
Yeah, go for it.
So just on like the high-level practical side, so you've touched on like how you use this with setting up like complex streams of events for actual like DOM event interactions. How would this apply to this? I guess two-part question. How would this apply to non-DOM events?
Mm-hmm.
Like we can use this with maps and things like that. Explain from a high level why that would be useful. And then can you give like a practical application example of where this might come into play?
Sure. So I have this demo here for the integration with, so all these being a data-driven kind of framework, CanJS spits out all these events from the data. We have computes, we have maps, we have lists, and all the derivatives of those three. Now, using something like can event stream or can bacon, you can take those events, turn them into first-class objects, very easily manipulate them, and then send them around, possibly even piping them into other can maps, can computes, etc. Can bacon supports, well, can event stream supports bringing, taking events from one map and directly piping them into another map, and then piping them back into the original map, so you can synchronize two things at the same time. I'm going to show you some code here. So let's look at this. So this demo, we have a compute. There's another compute over here that's based on. So we create a property from that compute that's actually an event stream. We create a compute that's derived from that, and I'll just. So we have compute 1 and compute 2. And we can say compute 1, new value, and you'll see it changes over here and updates compute 2's value. We can also change compute 2 itself. And you can see like all of these, so these update each other. We have another event stream that keeps track of how many times something has changed. We have another event stream that keeps track, it watches for the changes going through all these event streams and merges them into a single array if I change those a few times. So you can do,
So can I just offer a summary, I guess, for those of us who are not using this every day yet?
Go for it.
Tell me if you think this is accurate. So it kind of lets you create, it gives you fine-grained control over creating like compute-style composites of other computes or other computable properties of maps and lists. That you have fine-grained control of like things like counting the number of changes and accumulating. In this case, recent items. So you're able to kind of composite, create composite objects of changes in the lower level events. Is that accurate?
Yep, that's pretty good, and all based on all starting from events that happen somewhere. So it's like if you could take like DOM events and turn them into computes that change values whenever you assign that value to the compute every time, and then you have this library of higher order functions that are generic enough that you can use across all computes, and you can, imagine if computes had all these extra functions that you could apply to them to combine them together instead of having to write more and more computes every time.
Well, and then creating the number of times change, for example, you wouldn't really be able to do that in the compute. You'd have to use event handlers with like a counter or something like that. But this would be like a one-liner, you're saying, in FRP land.
Yeah, times changed, where is this total? Yeah, so here you go. This is like grabbing the compute 2, maps it to 1, and then scan is basically like an incremental reduce. This is it. This is the entirety of the times changed code.
What is the map 1?
This one over here?
No, .map 1.
Oh, .map, it's like the map function on array. So basically every time that there's a new value on the compute, this is going to create an event stream that spits out the value 1. So basically it's just a stream of ones that fire every single time the compute changes. And then you just add them together over time, and that's...
Gotcha. Okay. Okay, so it's a better syntax for compiling data from computes and other compute-style things.
It also has really convenient. Another thing that this does is I normalized events from can map and can list, so you get a single kind of event object back, and you can take that object and put it into another map to like two-way bind them. So this is an example of these 3 lines. That's two-way binding between 2 maps. So those 2 maps will update each other.
this is also how you could actually create filtered apps
Exactly.
or transformed apps, like a life-bound transform map or filtered. Yeah, that would be cool because I tried doing that with the old ways, and it was kind of memory leaky.
Yes, that's another thing. You could have like minimally just maps and lists that update with the minimal number of changes based on the events that are coming through.
Can you walk through that line, the map 1 and map 2? I'm not quite following that code.
All right, so this one's pretty familiar. This is just a standard map, and it has an A and B property, right?
Mm-hmm.
Then we have map 2, and what this does is map1.bind is going to return an event stream of change events on map 1. So every time a change happens to map 1, be it well, actually, it's like this. It's like saying change. It's equivalent. So every time a change happens, we're going to spit out these change objects, and then we're going to turn those event objects into a can map. So toCanMap creates a new can map that is going to take those event objects as they come in and change that map whenever an event happens on that stream. Does that make sense?
Does it create a new can map every time, or?
No, this is one can map that it keeps live updated based on this event stream. Whatever comes from this event stream, and you can create these events yourself. Like there's ways that you can just like, for example, up here, I'm actually creating events manually and sending them down an event stream to create this recent changes stream. So okay, so now we have a map, and it's a regular map, but every time a change event happens on this can map, we're going to use that event to update the new map. And then finally...
Hey, quick other question. Are we getting the events for... Does it have the initial values of the first map already? Because I don't... Is there events being created for that one?
In this case, it does not. So these are... So the second map is not
So
going to have...
map 2 is empty.
Correct. If we do can this is what we need to do to get the right initial value, but it does not have the values initially, which means, you know, we have map 1 and map 2, right? So we can do map 1.adder A, let's set that to new val. Oh, what's going on? I messed something up here. I'm running like on a weird version of this, so I'm sorry if this demo doesn't work. But this can and will work when I actually get it working again.
What was the expected value there? It should be a new val, right?
Yeah. So basically, what I expect is map 2 to have a new value. That's what map 2 should have been.
Yeah. Okay.
Would it also add B in there at that point since it's synced up, or?
Sorry, you were muffled.
Sorry, would it have the B value in there too, since it's now kind of like synced the two of them, or?
No, it only goes off changes. So what happens is you get bind change.log. What happened? Map1.adder. I don't know what's going on here. Something messed up. It's weird. That should have logged.
Okay, one last question. So right now in all the examples shown us in the code here, that's all using just can.Bacon, right?
Yep, it's using can.Bacon.
So anybody could kind of download can.Bacon right now and add it to their current can.
They could. It's kind of unstable right now. I'm still working on the API. You can track this bug if you are curious as to progress. I'm going to continue working on it for at least the next couple of weeks. So this is a good time if you have opinions or ideas. This is a great time to voice them.
So then, what's going to be the difference between the can event streams and can bacon, your current can bacon?
So what can event stream is a kind of a generic plugin that exposes it monkey patches CanJS and exposes the idea of returning event streams, but it doesn't tell you what kind of event stream to use. It doesn't even include an event stream to come with it. So what it actually does is it gives you this API that you can implement. You can implement. It's just these 4 functions. You can implement it into Can. You write them into Can, and you can take any event stream library that you want, or write your own. And as long as you implement this, Can will be able to use your FRP library with the library semantics. It doesn't have many expectations as far as how the event stream should work, just that it can create them and hook them up.
Okay, awesome. Any, I think Josh covered a lot, but any questions right now or thoughts?
Yes. How does this relate to promises? I saw that you can incorporate them, but wouldn't some event streams actually replace using promises?
They might. Promises have their own semantics. They have the way they recombine, I think, is a little different from how you would expect event streams to work. You could replace them, or you can create event streams off promises, or you could create promises off event streams. It really depends on what kind of thing you're doing. I think the promise API has enough unique traits right now, with the way that you can return promises from promise handlers to chain them together. That's not something that event streams necessarily. I don't think they give you the same semantics for that. Thinking about it, at least your code won't look the same. Promises are more about making an asynchronous block of code look synchronous, and this is more about combining all these data pipelines going through your application. But they functionally they have a lot of overlap, yes, and you can create them from each other. And yeah,
Okay,
that's
cool. Any other questions for Josh?
Josh, can you just switch to the code once more?
This code?
Yeah. So you bind map2 to map1 and later map1 to map2, right?
Mm-hmm.
So it's two-way. How do you prevent infinite loops with triggering events?
In the case of this one, because CanJS doesn't fire, I believe it's because CanJS doesn't fire the change again if you set it to the same value.
Ah, okay.
I do have a syncing issue with lists that I have a to-do item to address because you can't do two-way binding between lists. Since it's splice changes and stuff like that, it gets confused.
Okay, thanks.
Mm-hmm.
I think this is all very cool. I think the challenge is going to be communicating practical use cases in a way that people can wrap their brains around. Because we're still kind of figuring that out right now, but we'll have to do a really good job of making beginner-friendly tutorials showing kind of the advantage of this style.
Absolutely. As part of this, as part of the whole kind of event stream thing, you can expect having actual guides that show you how to write components using event streams, give you some neat things that you can do. That's going to be part of the whole kind of event stream effort. Hopefully it works out. It's kind of a big experiment.
Cool. Work.
Cool. Unless there's any other questions, we've had quite a few. Like I said, it's a lot for us to all take in. So,
Chris, do you want to point out Veljko's gist real quick, so people know where to find that? I don't think people watching on the YouTube channel can't see the notes in the chat.
Yeah, I'll add them to the YouTube page. But then you went ahead and you sent over the the issue, Josh, but if you want to send over the gist too of your kind of demo code, that'd be awesome. Okay, so I guess further communication for now is going to be on the actual the GitHub issue 1218. So other than that, thank you to Veljko, to Josh Dean, and to Josh Marshall for sharing today. And we'll be back next Friday, and we'll talk to you guys then. Thanks a lot. Thanks, everybody.
Thanks, Chris.
Bye.